Look around your city. See those massive concrete bridges, highways, and skyscrapers towering above you? They look completely indestructible. But modern concrete actually has a dirty little secret. It only has a lifespan of about 50 to 100 years before it starts cracking and crumbling apart. Inside our concrete is steel rebar. Water gets in, the steel rusts, expands, and boom, the structure destroys itself from the inside. Now, let's travel back 2,000 years to the coast of the Mediterranean Sea. The Romans built massive harbors, breakwaters, and piers right in the middle of the crashing ocean waves. By all modern engineering logic, these structures should have been completely washed away centuries ago by the salt water. But they weren't. In fact, many Roman seawalls are still sitting exactly where they were poured. Not only have they survived 2 millennia of violent saltwater battering, but scientists have discovered something absolutely mind-blowing. The Roman concrete isn't just surviving, it is actually getting stronger over time. The longer it sits in the ocean, the harder it gets. Modern engineers are spending billions of dollars trying to figure out how to make our concrete last longer. Meanwhile, some guy in a toga 2,000 years ago mixed up a batch of dirt and volcanic rocks that casually outlives our most advanced chemistry. So, what was their secret? Did they have magic? Alien technology? Or did they just get really, really lucky? To find the answer, we have to consult a guy named Vitruvius. He was a brilliant Roman architect who lived in the 1st century BC. He wrote a massive 10-book survival guide to Roman engineering called De Architectura. Inside this ancient manual, he left us the exact recipe for the Roman superconcrete. And it reads a lot like a bizarre cooking show. Welcome to the ancient Roman kitchen. Today, we are baking an indestructible seawall to conquer the ocean. First, you take 1 part limestone. You burn it in a kiln until it turns into a highly reactive white powder called quicklime. Next, and this is the crucial part, you add exactly 3 parts of a very specific magical dirt. Vitruvius called it pulvis putiolanus. Today, we just call it volcanic ash. Mix this dry powder together, add some seawater, and throw in chunks of volcanic rock for some extra crunch. Pack it into a wooden mold, submerge it in the ocean, and voila, a structure that defies time itself. For decades, modern scientists read this exact recipe and thought, okay, it's just lime and ash, nothing crazy. We tried recreating it in our labs exactly as written, but our version still couldn't survive the ocean the way the Roman structures did. There was a missing puzzle piece, something the translation didn't quite capture, or something the Romans didn't even realize they were doing. The secret wasn't just in the ratio of the ingredients, it was about where they got that ash and how they mixed the lime. They were basically harnessing the raw, chaotic power of an active volcano. But to understand the true magic of this dirt, we have to look closer at a so-called careless mistake they left behind. For centuries, whenever researchers examined Roman concrete, they noticed tiny, bright white lumps scattered throughout the mix. Modern experts dismissed these as lime clasts, basically evidence of sloppy mixing by lazy Roman workers. They figured the Romans just didn't sift their materials properly and left clumps of unmixed quicklime in the batch. But in 2023, a team of researchers from MIT decided to look a little closer at these so-called mistakes. Under high-resolution mapping, they realized these lime clasts weren't accidents at all. They were extremely specific chemical structures. The Romans weren't sloppy. They were executing an advanced technique called hot mixing. Instead of adding lime that was already slaked with water, they threw pure, dry quicklime directly into the volcanic ash and then added seawater. This triggered a violent exothermic reaction. The mixture heated up to incredible temperatures, baking the concrete from the inside out. Because the mix was so hot, some of the lime didn't fully dissolve. It formed those tiny, brittle white chunks, the lime clasts. And here is where the absolute genius happens. Fast forward a few centuries, A tiny crack forms in the Roman seawall. Seawater rushes into that crack, but before it can destroy the structure, the water hits one of those unmixed white lime clasts. Because the lime was mixed hot, it's brittle and highly reactive. The seawater instantly dissolves it, creating a calcium-rich solution. Within weeks, this solution recrystallizes into solid stone. The crack is completely glued back together. The Roman concrete literally heals itself. It is a living, breathing rock that uses the ocean's own attacks to make itself stronger. So those lazy, sloppy Roman workers? Turns out, they were some of the greatest material scientists in the history of the world. With this self-healing, super-strong concrete, the Romans didn't just stop at building simple harbors and seawalls. They decided to pull off the ultimate architectural flex, the magnificent Pantheon. This temple features a massive, perfectly spherical concrete dome that spans over 142 feet across. For context, modern engineers would never attempt a concrete ceiling this huge without a thick skeleton of steel rebar holding it all together. But the Romans? They didn't use a single piece of steel reinforcement, not one. To build this, without the entire roof instantly collapsing under its own crushing weight, they had to be incredibly clever. They poured the concrete in strategic layers. At the thick base, they mixed in heavy travertine rocks for a solid foundation. But as they built higher, they swapped the heavy stones for pumice, a highly porous volcanic rock so light it literally floats on water. And at the very top, they left a 27-foot-wide open hole called the oculus. This wasn't just to let the sunlight in. It cleverly removed the heaviest part of the ceiling entirely, preventing the dome from collapsing. The result of this engineering masterpiece? Nearly 2,000 years later, the Pantheon is still standing perfectly intact in the heart of Rome. It remains, to this very day, the largest unreinforced concrete dome in the entire world. Nobody has ever beaten their record. It has survived countless massive earthquakes, brutal barbarian invasions, and the complete collapse of the Roman Empire itself. Whenever the ground shook and micro cracks appeared, rainwater would seep in, reactivate those magical lime clasts, and heal the dome automatically. But if this ancient recipe was so flawless and indestructible, why did humanity completely forget how to make it for over 1,000 years? In the year 476 AD, the Western Roman Empire officially collapsed under the weight of invasions and internal chaos. The secret of their self-healing concrete wasn't just a recipe written on a scroll. It relied on a massive, highly organized, global supply chain. To make the indestructible concrete, builders absolutely needed that specific volcanic ash from the Bay of Naples. When the empire fragmented into chaotic, warring kingdoms, shipping thousands of tons of ash safely across the sea became impossible. Without the ingredients, the knowledge became useless. Vitruvius's great architectural manual was tossed into dark monastery cellars and forgotten. Humanity entered the Dark Ages, and we completely lost the ability to make liquid stone. For the next 1,000 years, medieval builders had to rely on stacking heavy carved stones and gluing them together with weak, crumbly mortar. It was a massive technological downgrade. Buildings took decades to construct and were nowhere near as durable. It wasn't until the 19th century that humanity finally figured out how to make strong, artificial rock again. In 1824, a British bricklayer named Joseph Aspdin patented a new invention he called Portland cement. By burning chalk and clay in kilns at extremely high temperatures, he created a powder that hardened powerfully when mixed with water. It was an absolute miracle material. It cured quickly, it was strong, and you could mass-produce it anywhere in the world. Portland cement became the foundation of the modern world. Today, practically every skyscraper, highway, and dam is built with it. But as we learned earlier, Portland cement has a fatal expiration date. It inevitably cracks and lets water destroy its steel skeleton. And even worse, our modern miracle material is hiding a dark, toxic secret that is quietly suffocating the entire planet. The process of baking limestone at extreme temperatures to make Portland cement releases a staggering amount of carbon dioxide. In fact, if the concrete industry were a country, it would be the third largest polluter on Earth, producing about 8% of all global emissions. Because our bridges and roads crumble so fast, we constantly have to demolish and rebuild them, pumping even more carbon into the sky. We are stuck in a toxic loop. And that is exactly why those scientists at MIT decided to look backward to move forward. They realized that if we could borrow the ancient Roman trick of hot mixing and intentionally add those magic lime clasts into our modern concrete, we might be able to create a hybrid supermaterial. So, they went to work. They fired up the lab equipment, recreated the violent exothermic reaction, and successfully poured a modern block of self-healing concrete. Then, they deliberately cracked it and ran water through the gaps to simulate years of harsh weather and structural damage. Within 2 weeks, the water reacted with the lime clasts. The crack crystallized and completely sealed itself shut. It worked perfectly. The Roman secret had been resurrected from the ashes of history. Think about what this means. If our modern roads, dams, and skyscrapers could heal their own cracks, they could last for centuries instead of just a few decades. We wouldn't have to constantly tear them down and rebuild them over and over again. This single ancient trick could drastically cut global cement production and take a massive bite out of our carbon emissions. But there's just one huge problem left. How do we actually scale up a 2,000-year-old recipe to supply the entire modern world? The modern world has a massive appetite. We produce about 4 billion tons of cement every single year. To replace all of that with the exact Roman recipe, we would need an astronomical amount of volcanic ash. For the Romans, this was easy. They lived right next to some of the most active volcanic regions in Europe. But today, there simply aren't enough active volcanoes on Earth to safely supply a global construction industry. And even if there were, strip mining entire volcanoes would be an absolute environmental disaster of its own. So, modern material scientists had to figure out what actually makes volcanic ash so special in the first place. It turns out, pozzolana is essentially just a material packed with reactive silica and alumina. That's the real magic. And if we know the chemistry, we don't need a volcano. We can fake it using modern industrial waste. Alternative number 1. Fly ash. This is the extremely fine, toxic black powder left over from burning coal in power plants. Alternative number 2. Slag. A glassy, highly reactive byproduct that gets skimmed off the top of molten iron during steel making. And alternative number 3. Calcined clays. Basically, just taking common, abundant dirt and baking it until it acts exactly like volcanic ash. By combining these modern waste products with the ancient Roman hot mixing technique, we create a hybrid superconcrete. It heals its own cracks, and it's built from garbage we were going to throw in a landfill anyway. It is a massive win-win. We get indestructible infrastructure, and we slash global emissions by recycling waste. So, why aren't we building literally everything out of this right now? Well, because the construction industry is terrified of one thing: risk. The modern construction industry is built on extremely strict safety codes, regulations, and liability. If a contractor uses a brand new experimental hybrid concrete and a bridge collapses, they will get sued into absolute oblivion. So, most builders just play it safe. They stick to the standard Portland cement, even though they know it pollutes the earth and won't last. But we are running out of time. Climate change is a ticking clock, and the planet cannot wait for a 50-year trial period. Fortunately, the MIT team and several bold startups refuse to wait. They are already commercializing this self-healing Roman technology. They are running real-world pilot projects, proving that we can build stronger, greener, self-healing infrastructure today. It is the ultimate collaboration. a bridge built across 2 millennia of human history. The ancient Romans didn't have computers, advanced GPS, or degrees in molecular chemistry, but they were master observers of nature. They saw how volcanic ash naturally turned into solid stone when it mixed with seawater, and they harnessed that raw, natural power to build an empire designed to last until the end of time. We built our modern world for speed and cheap convenience, and now it is crumbling beneath our feet. If we want our civilization to survive for the next 2,000 years, we need to stop thinking like modern consumers and start thinking like Roman engineers. If you want to uncover more lost secrets from the ancient world, hit that subscribe button. Thanks for watching Rome in Minutes. See you in the next era.